terms of general purpose robots where they can solve all kinds of problems and figure out what problems they need to solve, that's probably 5, maybe 10 years away. What we do is we use direct image to voxel neural network. So robot essentially takes the images that are coming in through the camera and turns it into a 3D voxel map of the entire space. The robot comes into a home, it has no idea where it is, what it is, and just like another human being, you would just walk around and build a map. In the same exact way, it just literally starts exploring and building map on the fly.
Mehul, I'm super excited about this. I think I've been on the Matic waitlist and had an order in for a long time. Been a big fan of what you're building.
Thank you.
And I'm super excited for this conversation. Do you want to kick us off with sort of what you're building? And actually, like you have a bunch of like visuals we can show. Do you want to show folks and sort of talk through it as we walk through this?
Absolutely. To set it up, just to give a little bit of an understanding before I jump in a visual, we started Matic in late 2017, officially incorporated in late 2017, 2018, with a realization that there were about 200 plus self-driving car startups back then, equal amount of industrial robotics companies. But when we looked at home robotics, it was really just iRobot and Roomba, which has been around for now 23 years and hasn't changed a bit. So it just sort of drove our curiosity that why this particular space hasn't really seen innovation, because the problems that every one of us face in homes, which is daily chores, is obvious, universal. It's not like we had some secret. So aren't there 200 people, 200 plus startups in this domain? And that sort of piqued us our curiosity, and we just came to this conclusion at a very early on after doing some digging for about a month, that we felt like the entire space of indoor robotics was built upside down. It's like putting a cart before the horse. And what I mean by that is if you're trying to build self-driving cars, I think Sebastian Thruni is very famous for saying this, that first thing they did was build Google Street View. And what Google Maps or self-driving cars have is Google Maps and a GPS. So car knows where the road is going and where it's located on the road. So regardless of the sensor stack, those are the two missing critical pieces of the puzzle that were missing. In an indoor environment, whether it's home, factories, malls, airports, how do you know if you're on the right side of the couch or the left side of the couch, right side of the table or the left side of the table in a cafeteria or not? So this precise localization isn't available in an indoor space. Indoor world is also cannot be mapped the way we mapped Google Maps because homes are private. So how do you give a robot an ability to self-map, self-update that map in a dynamic environment and be able to navigate it precisely, regardless of a changing in lighting? Well, that requires vision. And that requires a lot of algorithms. And it turns out none of those things were built. All robotics approaches up till 2017, 18, not to minimize anyone's effort, they are amazing efforts, but they were all almost to the point where you're just throwing a bunch of sensors to a robot. So given a robot would be a Christmas tree of sensors, and then you're hoping that it will just be able to do it. But that's like having 20 eyes and no brain. So we just thought that there was a huge opportunity to build vision only robotics foundation to go solve this problem. So that's what we started doing. So I'll show that to you right now. So let's just quickly share my screen here. There we go. So we'll start with a couple of quick things here. So here we go. So this is a quick overview of the vision only stack we built. And the reason we went very much Tesla-like vision only approach is indoor world is entirely built for humans, by humans, to fit sort of our perception system, which is primarily vision based. So we just came to this conclusion that if you're going to build level 5 fully autonomous robots, whether they're humanoids or any kind for an indoor world, they have to have a same perception vision ability that we do. And that starts with the RGB camera. So here's an example of what we built. This is the robot, Matic Robot. It's a first floor cleaning robot with vision only autonomy on the device. We have 5 cameras. I'll pause for a second, but this crown, this black crown that we have on the top, we call it a crown, that contains entire sensor stack. And there are 2 cameras in the front, 2 cameras in the back, and there is 1 camera that's looking down, top down. So it's a 5 camera based system, and all computes on the device on NVIDIA Jetson or in Nano 4GB, so the cheapest computes we can find. It's robust in all kinds of lighting condition. And key pieces of the puzzle are live indoor mapping based on a long-term SLAM. And then what we do is we use direct image to voxel neural network. So robot essentially it takes the images that are coming in through the camera and turns it into 3D voxel map of the entire space. And each voxel is about 1 centimeter. So it has a precision up to 1 centimeter on the maps that it's building. And it's trained on photorealistic synthetic data as well as some real world data, and just works in any kind of environment. So
Mehul,
and the
what are
idea is, go ahead.
can you double click what are voxels for folks aren't familiar? I'm actually not super familiar with what voxels are.
Yeah, great question. So I'll go back little bit so it kind of shows. So voxels, think of it as a pixels. So if you go back and look at computers from 20 years ago, you have all these pixelated images. In the same exact way, voxels are the cubes. It's a instead of a dot, it's 1 centimeter by 1 centimeter by 1 centimeter cube that robot built. So then it's a three-dimensional version of a pixel in some ways. Okay.
That's
So
helpful.
this Yep. And once it's done building this map, so what does it look like? So to give you guys an understanding, what does it look like in a real home? So here's an example of it. This is literally my home, where the robot comes into a home. It has no idea where it is, what it is. And just like another human being, if you go into open house, you would just walk around and build a map. In the same exact way, it just literally starts exploring and building map on the fly of the home, and it will keep going until it has mapped the entire home. So, quote unquote, no longer any open frontiers are left for it to explore. And this is actually it going underneath the dining table and capturing it. And it builds about 3 feet of high map at the moment, um, all on device. So user don't have to worry about that privacy. And the idea is that when it builds this map, it's not just once a map. It continuously keeps doing it every time it goes around and adds more and more precision to it. And ultimately, once it's done exploring to finish, it ends up building a map like this. So this is ultimately the final result that user as well as robot have. And the advantage now is that now as a human being, you can see what rooms it has mapped, what areas it has mapped, and now you can use these rooms and landmarks as a way to give robot an instruction. So in this particular section, you can say, "Hey, go to the room with a gray carpet or gray floors and then clean it, or go where the coffee table is and clean the rug over there." And all kinds of semantic oriented instructions, natural language instructions are possible based on the maps that's built here. And the crown that we've built can really go up and can be used in a different kind of robot. So it's not just about our own. It can be used in a different kind of robot. And here's a good example of it. So this is where what we did is we took the 5 camera based system, and instead of having about a 10-inch tall robot, which is what Matic's first product is, we actually put it on a 3 feet tall robot. And then it just started moving around. And on the right side, you can see how it's actually building that full map of our entire office kitchen with 6 degrees of freedom. And we've always believed that as a robot, if you can see it, you can explore it and build a map around it. If you can see it, you can navigate it. If you can see it, if you can avoid obstacles. If you can see it, you can clean it, manipulate it. So that's where the system was, that we spent more time focusing on the visual brain of the robot versus the application itself. And then we chose floor cleaning as the first beachhead, because by definition, if you're cleaning floors, well, you have to explore every inch of a surface and clean it. So it allows you to build map. Floors get dirty multiple times a day. So a robot goes into your home and cleans. It's constantly changing and looking at the environment and updating the map dynamically as well. And this is where we get to, and it's a real need. Market already exists. We don't have to educate customers on why they need this robot. So it's a perfect first product, perfect beach, right, to get inside consumers' homes, earn their trust, showcase what Tesla FSD for homes would be look like, and then go build second, third, fourth product.
I love that so much. Something that I've seen as just a really quick one is how much people
Mhm,
have talked about how cool the like unboxing experience is for Matic, where like you just kind of
mhm.
the robot, like you take it out and it just like goes and does the sort of mapping and it roams around and like you get that super high fidelity mapping. How much of that was like just the constraint of solving this problem versus like trying to like start people off with this magical experience? Like did it just happen to be that that product experience was like just what needed to happen, or like was it intentional to make that like magic at the beginning?
Oh no, no, it was absolutely intentional. And the reason I say that is robot, if which is we don't want robot to be pets. We don't want robot to be another human being. They're not that smart. But we want robot to have its own category of personality. Intelligence is about motion and movement. So the moment a robot comes to your home and you have to take it out of the box, it defeats the purpose. If it's genuinely an intelligent robot, it has to roll out of the box. It has to start doing the work. So that was always the intention that I shouldn't have to do a lot of work to set it up. Because if I did that, by definition, it's not that smart.
I guess kind of diving into the edge device only, you think about a lot of
Hmm.
the AI models currently heavily on cloud processing, but Matic obviously operates entirely on device. So I know you kind of alluded to the fact of privacy being a big kind of player in
Hmm.
that decision, but what bottlenecks or hurdles were you facing when trying to create the tool that was truly edge device only?
Great question. So we started with this idea very early on that if you're building humanoids or any home robots or even floor cleaning robots, you don't want a robot that says, "Oops, I fell down the stairs because Wi-Fi was too weak for cloud information or cloud connection," or "Oops, I bumped into your kid because I didn't get the decision that obstacle was there." So, and as a human being, we don't have a hive mind. We actually make a lot of decisions on the fly. So low latency was a huge priority. And the moment you add I think there is some rule that the distance you have to the cloud is the amount of latency you'll add at that exponentially, something along those lines. I don't know, remember, but that's the way we thought about it. The first priority is low latency, which is can it instantly stop in front of a running kid or a running pet. Right. The second one was privacy, which is having worked at Nest prior to this. I was the lead of Nest Camera product portfolio. So having worked at Nest, shipped a lot of cameras, I know that families really, really care about their privacy and they really do not want their home data to be going to the cloud. And it never made sense to us that why do I need to jeopardize the privacy of my family to literally have my floors cleaned, right? So in that scenario, having a robot that made all the decisions on device was really critical as well. And then the third piece of puzzle is if you do all the computes on device, then it can take its data that it's seeing on a daily basis and actually self-learn ultimately as well. Because these robots, if they are built for homes, they are going to sit on the dock mostly at nighttime when we're sleeping, or there will be some charging time. And at that point in time, they are connected to power. And even if they are low powered, I mean, NVIDIA GPU is still, Orin Nano can still do about 40 tops of compute. So you can use that to do a lot of self-learning on the device for that particular home as well. So all those scenarios led us to pushing this on the edge device. And in terms of constraint, we've always believed that if you that what we do is what we refer to as a product focused research, which is we just decided that it has to be on the device. So now let's actually go and build models and distill models that are going to fit on the device. And because of that constraint, you start in that way and you actually get there. And obviously it's hard. It slows you down. But in the long term, it's hugely beneficial, not only from privacy perspective, but also cost of cloud as a company that we don't have to absorb or think about as we scale.
Yeah, I was going to touch on that quickly too, because I saw something about how you're able to keep your costs extremely low. And again,
Hmm.
unlike a lot of other AI companies that spend millions on training these large models, I think you kept your cost under 1 million. So can you explain how
Correct.
Matic actually achieves the state of the art robotic intelligence with minimal compute and data?
Correct. So great question. So we apply what we refer to as the information bottleneck principle in the sense that we as humans, if you think about it, I think, okay, I'll take a step back. I think there was some demo I saw on Aloha where they tried to do shoelace tying, and after 26,000 demos, it was able to do simple one at 70% accuracy and complex one at 30% accuracy. Well, I have a 5-year-old and I haven't given her 26,000 demos, and she's able to tie her shoelaces pretty well. So we clearly do not need tons of data, and that's because there is a theory that we apply information bottleneck principle where we take certain data and are able to abstract it. In the same exact way, we decided that the first thing we want to do is give robot an ability to build this high fidelity 3D view of the world, because physics and 3D geometry doesn't necessarily change. So once you have that physics aligned walls are there, now you can use that as a constant in information battle, like and create all the things around it. And that allows us to solve the problem. So we essentially boil the problem down to precise 3D understanding using stereo camera, and then applying very robust long-term SLAM system on top of it, which is, and SLAM stands for simultaneous location and mapping, which has been around honestly for about 25 years. I think math for SLAM was worked out in 80s, but we realized that almost all open source implementation, the analogy is literally like a pre-iPhone touch interfaces and post-iPhone touch interfaces. In the sense that touch interfaces were around pre-iPhone, but you had to jab your finger all the power it can muster to make it happen, make it do things, and then it became silky smooth. In the same exact way, when we went out and realized that all open source SLAM system at best are about 70% accurate. So can we push the needle to the nth level and build this precision? If we can solve that problem, then we do not need to have a large context in the memory to be able to navigate. We can just actually take this as a constant and use that as an information bottleneck to solve the problem.
Yeah, and how much, sort of building on Nolan's question, how much of this historical arc of the company, and you mentioned like all the way back to 2017, 2018, when the company was created, you've been working on this problem, and sort of now here we are in 2025, and like you're sort of hitting scale as far as deliveries go of Matic robots, and I have mine coming hopefully in March, which I'm excited about. But
Likewise.
like how much of that arc was like the actual vision technology wasn't ready from like a research standpoint, like just being like slightly ahead of the curve? Because obviously like even full self-driving back in 2018, like, you know, it was kind of like a toy demo versus like the just challenges of like building hardware and actually like shipping a consumer product. Like how did those stack up?
Oh, that's a great question. I'll take a step back and admit that I don't think what we are trying to do would have been possible prior to 2018 or 2017. There were two trends that we saw emerge, and we were part of Nest and Google. So first thing, my co-founder and CEO Navneet, he actually helped spec out Google Coral TPU from Nest perspective. So we knew these AI chips are coming out because he was a computer vision lead at Nest for Nest cameras, and second thing, we knew that we saw all the self-supervised learning algorithms emerge, some of the synthetic simulation database results emerge. So we just came to this conclusion that these two trends would have a huge impact on robotics. And now was the right time to do it, because in a startup, you know, the analogy for a startup is timing is really hard. And timing wise, the best analogy is that you can't really create a wave, you can only catch the wave. So we just felt like, okay, robotics wave is coming, let's get started. And honestly, first 2.5 years, computes weren't ready because NVIDIA Orin Nano literally came out early 2023. Prior to that, even a lot of these algorithms weren't ready. And at the moment, we see tons of startups starting in robotic space around observability, simulation, infrastructure on how to even see what the system is working. We had to build all of that ourselves. We have our internal systems all for every single piece of the puzzle, because many times we got to 97.8% accuracy, for example, let's say in SLAM, and now you're going to 99.9. Well, how the hell do you actually measure it at a scale? How do you know in a so for that, we have to invent the infrastructure, we have to invent the QA tools, we have to invent the observability platform, and we did all of that. So a lot of work is both vision oriented in terms of pushing the algorithms as well as the infrastructure needed to solve the vision problem.
And as a follow-up to that, like how much of the current AI, generative AI moment has like actually had an impact on you all? Like would it, like I'm assuming like back to the models that you're using and the technology you're using, it's like somewhat disconnected, but like I have to imagine there's like at least some parallels to like vision language models.
Absolutely.
And stuff like that. Like what's the correlation between the two?
Great question. So I think Dr. Fifi Lee coined the term, and maybe it was popular, but she made it popular, at least into mainstream, on a spatial intelligence or spatial AI. That's what we really do. That's the foundation. But yes, there is a correlation to some of the VLMs and stuff. So what I showed you, the visual map, a structured map of the home, that's the kind of map our cats and dogs have. But you can't tell your cat or dog to go sit in front of the couch and watch TV. They don't understand what couch is or what TV is, right? So semantic understanding is missing. So what we are doing is taking advantage of some of the VLMs and actually open source VLMs like Dino and extracting image level embeddings out of it, turning into a pixel and voxel level embeddings. So each voxel in our map actually knows what it belongs to. So now you can start querying it. So I can just kind of, if you're Let me just show you a quick demo of this thing as well. But what we can do now is once we have a map like this, here's a good example of it. So even, this is a map of my kitchen. I'm able to see it, but it is sort of janky and not necessarily perfectly clear. But even because each voxel space knows what it belongs to, just like you ask ChatGPT a question or Gemini a question, you can start asking questions here and say, hey, where is chair in this particular map? And it highlights chair or kids table or aluminum garbage can or mess from cooking. And this is really interesting. So when we say food spills on the floor or mess from cooking, what it's doing is extracting some of the VLM understanding that the floors are likely to be dirty around the cooking oven or the garbage can or near the dining tables, and it just highlights those spaces in a probabilistic way. So it doesn't necessarily know that this is where the dirt is, but it knows what is the higher probability of dirt area. And now it can go and look for it and clean along those lines. So all kinds of interesting things are possible because of it. And technically, I'll show you one sneak peek of what's coming down the road, even with Matic, because obviously we're all excited about manipulation, and we always believe that manipulation, people think manipulation can only happen with hands, but we're a product people, so how do we make current technology useful? So for us, the idea was that why can't we just tell Matic to say, hey, Matic, put the shoes in its proper place? And now it just pushes it out of the way. It has the power, it has an understanding, and it can ask VLM, is the shoes movable object? Is it a heavy object? Where is the shoe rack? All this information has understanding, so it can just push it close to it and put it in a proper place. So all kinds of interesting things are possible even on the floor cleaning robot that we built.
Well, I have to give this very personal example, which was I was telling my girlfriend that I ordered the Matic Robotic last night, and she was telling me,
Yes.
she's someone who loves to have a clean space, not a neat freak, but like
Hmm.
wants the space to be cleaned. And as we were watching
Hmm.
some of the videos, her reaction was, "Oh, so it's just going to like basically find a bunch of the objects and then like move around them, and like it's not actually going to clean." And like she wants it to like go and kind of manipulate the space to like actually make sure it's fully
Yes.
clean. And I love this. She's going to be thrilled to know that the objects will actually be
Yeah,
somewhat movable in certain contexts, and that it will be able to clean those spaces. So I feel like this is like
that's correct.
such a real problem that it's able to solve in a unique way. How, like, can you touch a little bit more on how accurate it is at doing that? Like, will it be able to like, you know, shoes is a good example because, or maybe it's like a low hanging fruit example, but like how much farther can that go? Like in the future, is the intent to like add more ability for it to manipulate like the environment?
Absolutely. A great question. So, and you're touching on the key challenge of robotics, which is how accurate it will be. I think this is the fundamental point of what makes robotics hard, right? You take a step back and think about consumer robotics. Well, the largest company in the United States on a consumer robotic is still iRobot at 50 million robots. Then Shark Ninja has caught up. But then the next highest robotics deployment is literally 750,000 Amazon Robotics in warehouses. And I know that there have been lots and lots of amazing demos, and Boston Dynamics has pushed needle on hardware and humanoids much, much farther ahead. But purely from a product point of view, they only have about 1,500 deployments, if I'm not mistaken. So just shipping the robots and making them useful is really critical. So for us, the way we've always thought about it, and the reason this idea came, is we've been very clear that no one actually wants robots. They want solution to their problems. And robots are a means to an end, just like in AI is. And in robotics' case, the solution to the problem has to be 99.9 or even higher percent accurate. The reason being is that we go to school to learn coding for 4 years, or image generation for 4 years, or video editing for 4 or 5 years. And when AI gets it 90% of right, we get mesmerized. But in our case, for example, just for a floor cleaning robot, well, we don't really go to school to figure out how to navigate around our home without bumping, or how to vacuum our home, or how to pick up a glass 100 out of 100 times, right? If you just have a 99% accuracy and you're picking up a glass and it breaks 1 out of 100 times, that's still not good enough. We're probably going to fire a domestic help who breaks one glass every month, right? So the robotics bar is insanely high. And for us, the way we think about it is what problems can we solve at the 99% accuracy level and keep building that and shipping that. So it will start with shoes. Then the biggest this is not unexpected, but biggest feedback we get from our customers is, can you just clean my toys, my kids' toys? If you do that, that already is a huge help because they're all over the place. They constantly throw things around. So yes, we can't pick it up yet. Picking it up and putting it in a proper place is the ultimate nirvana. That's where we want to get to. But what if we can just push it into the corner? What if I can just kind of create a pile of it? That's still much easier. So the idea is, what are the unbreakable items? What are the soft items? What are the easier to deal with items that we can push out and push in way? And if we can solve that problem, that's already is utility. That's already is helpful. And then we can scale it to a much complex object. And that's not all that different from how we treat our own children. We don't give them knives or glass or any sort of sharp items until they're 8, 9, 10, right? Initially, they get soft toys, then plastic toys, then even a very unbreakable objects. So in the same exact way, we start robot doing that until they learn how to really manipulate it, and then we can trust them with more expensive items or breakable items.
I'm curious to get your thought on this, Mehul. Obviously, Logan and I have been able to sit down with a lot of folks building in this space. I would say the majority of folks are obviously building on software, very small when it comes to hardware. So I'm curious to pick your brain.
Mm-hmm.
Because you think of software, very easy to iterate, can kind of have maybe a quicker turnaround. What advantages do you think there actually are for building on hardware, if there are, or kind of how you compare the two landscapes?
Yeah, great question. I think there is a quote by shoot, Alan Kay, sorry. Alan Kay has this amazing quote, which is, I believe, a fifth slide on iPhone keynote that Steve Jobs had in 2007, third or fourth or fifth slide. And that quote says that if you're serious about software, do your own hardware. And he's always been this of a believer that vertical integration and building your entire widget is really critical. The reason being, and as a product person, I'm sure Logan has a different opinions and would have opinion, but at least over the years, as a product person, what I've learned is there is no such thing as a perfect product. There is only simple product and a complex product. And a simple product is all about experience. So if we look at, various, let's say, smartphones today, whether it's a Samsung, Pixel, iPhone, these are all different experiences. They all have exactly the same set of features. There is really nothing drastically unique left in either of any of those devices. But each experience is different. An iPhone experience is vastly different than Android or Pixel and then Samsung. And people gravitate towards what experience resonates with them. So in the same exact way, vertical integration really allows you to build that tight coupling of an experience that is really necessary for robot to initiate. And the way to think about this is, if you just build software, you're saying that, hey, I'm going to build a brain. But if I had an amazing brain but no fingers or hands, I really can't execute. And if someone else built these fingers or hand, if I got a third party hand and put it on me, it still doesn't work the same way as what God gave me as a original body, right? So that's really the analogy that and I think in robotics is even more critical because you have multiple systems that has to connect at a very tight coupling level for it to work. And that's why the other way to say it is, the other argument, if you look at the flip side, is that in robotics, building prototype using ROS or multi-sensor approach is relatively easy, but there is literally Kickstarter campaigns after Kickstarter campaigns of robots that were prototyped and funded, but they never shipped, or if they shipped, they were prohibitively expensive because turning that into a product actually is much harder.
Yeah, and I think one of the advantages for you all sort of controlling both pieces of the stack, and actually this is the Tesla autopilot is a great example of this, in that like the pitch to customers originally was, hey, this Tesla is actually just like a piece of hardware that is a test bed for software. Like the software is going to improve over time. And I'm curious, like how much of that is part of the strategy as well of like, is the intent to just like, keep shipping over the air software updates to customers to like, let them, have new capabilities come and all that?
100%. That is the thing. In fact, not every single feature we intended to ship on our website and started talking about it on the website is available. These are the features we're shipping across the board. And part of the reason is not that you only want to ship the feature, you also want to improve the accuracy. Now, unlike, self-driving cars are insanely obviously hard, but the part that is troubling or tough for them is if you make a mistake, mistakes are fatal almost always. For us, mistakes are trivial Some mistakes like falling down the stairs, deadly sin. Going over a dog poop, deadly sin. Not even finding your own dog and running out of battery in the middle of a home somewhere is a deadly sin. So these are the things we take seriously. But if it once in a while ran into a chair at a zero point 0.3 miles per se or zero point 0.3 meters per second, which is relatively slow, it's not the end of the world. So it does afford us an ability to ship robot before it is, as I said, perfect or at the accuracy level, and then continuously improve on top of it. And what we wanted to build was this foundation that we're doing, and now we're really pushing the needle on manipulation and things that we want to build on top of it, which is voice gesture detection and being able to just talk to it.
Yeah, and I feel like there's a really interesting personalization layer of this. Like this actually makes me think about like actually the risk profile for customers, and especially in their homes, is very different. Like you might be in
Hmm.
some place that has a lot of antiques, and actually like the zero point 0.3 miles meters per second hitting my antique, dining wood chairs or whatever, like actually could be like a significant, and like I can sort of tell you that like, hey, be really careful around, and like this goes back to
Precisely.
understanding the environment and being able to say these are objects that I care about versus like, I'm not really worried about the floorboards in my hallway or something like that.
100%. You're talking about exact things that we've imagined. We've always imagined that. Imagine that, if I hire someone to clean my home, that's another human being, another domestic person. They come, initially, they don't know my home, so they'll explore, get to learn it. But every time they come, they're actually customizing their cleaning methods to my preferences. Then once in a while, I do give them an instructions that yesterday night I had a party, so please pay extra attention to kitchen or family room, or kids just made a lot of mess around their room. So today, focus on that. So can you give that personalized information? Because as a user or as a homeowner, at a very high level, I want to live in a perpetually clean home with perpetually clean floors. I don't want to do it. That's requirement number two. I don't want to think about it. That's requirement number three. But then, very specifically, and this is especially true for my wife and generally homes with families where women put a lot of effort to create a great sanctuary, is that they want it to be clean their way. So it's not just that you want your home to be clean, you want it to be clean their way. So you want to give an instruction and then have a robot do it. So you're absolutely right. It's leading to that level of personalization and being able to do it. And for me, I'll give you another example on gestures and voice, where I had a golden retriever and we had a robot, and typically a robot would clean. But if I found his hair, which is really hard to see even for a human eye sometimes, somewhere in the corner, if it's a robot vacuum of any disc robot or today, I have to hope that in this magical algorithm it comes over there and cleans it. If it doesn't, I'm shit out of luck. And for me, I was like, no, if there was another person cleaning it, I would just tell them, hey, there is a hair loft over here. Why don't you come back and clean this here? Well, why can't I do that to a robot? Because even I'm always going to be, at least for foreseeable future, smarter than the robot itself, and I have my preferences. So I should be able to tell it that, hey, there is still dirt left here. Come and get it. And that's where being able to point where the dirt is, being able to tell where the gestures are, all those stuff is really critical.
We kind of started this thread before recording. I think it'd be interesting for the audience to hear as well. We were talking about obviously how you scale hardware, robotics versus software, and some of the bottlenecks and issues that come along. And I think you had a really cool analogy kind of with the coffee shop. So we'll let
Hmm.
you kind of expand on, again, as you're ramping up, trying to get as many units out there as quick as possible, what that looks like for you
Yeah,
and how it kind of varies.
yeah, we can start with the coffee shop. And another favorite analogy that I'll do it is, as a product and a admirer of great products, the product and a company that I absolutely love is In and Out. If you're in California, you've tried In and Out Burger, and it fascinates me to no end that they haven't changed their menu for 80 years, never ever touched their menu. It still looks like you just walked into a diner from 50s. Turns out it literally started about 20 miles away from McDonald's as well. It's gone through three generations of owners. Um, uh, and has never lost its ability to just deliver great food or great burger. And it never advertises. You've never seen an In and Out ad. No one ever talks about it other than just word of mouth. And yet each In and Out store does 10x the revenue of probably a McDonald's store. So purely from a product perspective, what they've been able to do for 80 years is deliver the same exact burger with the same exact taste, with the same exact fries across the board, across the world. That's the scaling, and that's insanely hard because a lot of companies start doing very well, but over time they lose the quality. Over the time they lose the character. Coffee analogy was very simply that if you make an amazing coffee today in your home, and turn it into a shop gets successful. Now imagining opening up a same coffee shop in London or somewhere in the middle of the Africa and trying to do the exact same ingredients. And at that point in time, making that same exact coffee with the same exact ingredients is insanely hard, partly because even the climate change actually makes an impact on your coffee. There are so many hidden moisture or temperature or just the sheer preservatives that might be used along the way, or staleness of transferring the beans that can impact the coffee. So making something exact copy for a million things is much harder. And it's harder in software, right? The best way to say it is, let's say you built an AI app. It works amazingly well for 10 customers. Now, all of a sudden, tomorrow you got 100,000 customers. It's not going to work the same. You have all these scaling problems. So even in software, you run into a problem. So hardware, it's almost impossible to make go from 1 to 1 million copies and just say, okay, I'm going to throw money and it will work. There is a lot of work that goes along the way.
And I think an
Atoms are much
interesting
harder.
Yeah, and I think an interesting point you just kind of brought up too. There's so many different AI platforms now. So I can go on, try
Mhm.
something out. If it doesn't work, great. I'll just go Google search another platform that
Yes.
does exactly the same thing. I feel like hardware is different though, because again, you go through the process of pre-ordering it, it gets shipped out. Now you
Hmm.
have it. So it really
Yes.
is kind of like a make or break. I have this for the first week. Does it actually solve these issues? Is it doing what it's doing? If not, do I solve it back? Like I feel like that customer acquisition process is a lot more
It's
pivotal to hardware than any software organization building right now.
absolutely. And it's also, so hardware, even if you're building MVP and just shipping a basic product is hard because it is something, even if the honest answer is that if we wake up tomorrow and we have 10,000 orders, I have no way to go and ship it in next 2 to 3 months. All right. There will be a time it will take. So that's one piece of the puzzle. But the second thing is what we refer to for our product is what we wanted to build was minimum lovable product. And what I mean by that is when you are building a hardware of a product that has never been built before, whether that's the human AI pen or AR VR glasses, now you have a lot of opportunity to innovate and even ship partially built hardware. But if you're trying to invent a car today, you've got to have four wheels and you've got to have a steering wheel and you've got to have windshields and you've got to have your ABS brakes. It's not like 100 years ago when you could have gotten away with a crank as a starting engine or not have any roof or just have a convertible things or has a cloth as a roof. All those things are gone. Now there is a minimum set of features or benefits or things that people expect in a car. In the same exact way, because we were entering an existing category, there was minimum set of expectations from users that it will at least map, self-navigate, and clean very well. And that's the foundation that we start. And then we have to go on top of it. So what we have to build is what we refer to as a minimum lovable product. And that's even harder because it's not just that you're building MVP or quantum of utility. You're building the whole product and then innovating on top of it.
I just wrote down minimum lovable product. I'm going to steal that and update all my docs that say MVP
Oh,
to
please do.
minimum lovable product. I love that. That's
Yes.
great. Um,
Not my phrase. I will give credit to Gusto and their founders who were part of our previous company in YC Batch. Those guys did it, but I love that phrase. Yeah, minimum
yeah,
lovable product.
it's awesome. I'm curious to get your thought on why consumer versus like industrial slash commercial. Like it seems like there's actually, and maybe this is wrong, but like the total square footage maybe, or like maybe that's not true. And like, I've completely
Hmm.
looked at it wrong, but like actually just what's your sense of like the opportunity space with industrial commercial versus like people's homes?
Yeah. So it boiled down to two different things. One is what problem we're solving. If you're solving for consumer or homes, you're literally saving their time and energy because that's not most of the us in the United States cannot afford a domestic help. So we're doing cleaning constantly ourselves. So that's where it was savings of time and energy. Now in industrial space, let's take Google as an example. If I were to say that we're going to clean all Google offices, well, the cost of Google offices getting cleaned is probably a percent of the entire cost structure. And if I say 50% of their percent, it's just a money saving endeavor at that point. It's not necessarily a genuine problem where if it turns out that there is all of a sudden a huge shortage of a cleaning labor, that's where robots are great. And then you're solving a labor shortage problem. But here at the moment in industrial space, at least in this case, we felt like it was mostly a cost saving endeavor. And that's never as amazing or as sort of intense as a problem than just saving my own time and energy. That was one. And then the second thing is if you're going to jumpstart robotics the way we want to do, initially all hardware and economies of scale will only come from consumer space. That's where the reason we have this ubiquitous in a camera is because smartphones and cell phones proliferated and then created all kinds of economies of scale for all kinds of hardware, which allows us to do things that we are doing today. So if you're going to go and build this edge device AI and make it cheap enough to be ubiquitous, well, then scale is needed, and scale is only really there in consumer space at the moment. As we just alluded on, the max amount of robots that we see in the United States is 750K. So how do you get to million, 100 million, 10 million scales? And the way we saw it is every single home in the United States and probably world has vacuums, manual vacuums in their home. Not every single home. In fact, only about 13% of homes in the United States have robotic vacuums. So even though they've been around for 23 years, they've only penetrated about 13% of the homes. And that's because, you know, 20 years ago, they were amazing. For the today's world, they're kind of not that good. So there is an opportunity to say, how do you build a product that can be saturate the market 100% and genuinely save that time and give it back to users? So that's where we thought that consumer opportunity and consumer problem was far more intense, and that's where we wanted to go. The second part, and then this is the honest part, is that we built it from privacy perspective, but at the same time, just like outdoor world, indoor world does have a lot of long tail and critical maps and types of homes. And I've visited about 200 different homes now, and my God, they're unique. And there will be a long tail, as you kind of talked about, alluded to, very specific antiques that that users may have to different kinds of pots and pans or show floor pieces. And what we found out, this was based on our previous startup and Nest experience as well, is that when you build users, when you build a relationship with trust and tell them that, hey, we're not going to take your data and don't take their data, at that point in time, users actually are far more willing to share their data with you for specific places where you make mistakes. So we have more people opting in to share data, and we have users who've uploaded hundreds of gigs worth of video data just because they want us to help improve the product and help doing it. And this is where it becomes a relationship. So again, the scale, if data is the bottleneck for whether it's a generative AI or a spatial AI, sorry, um, data is critical, and this is where we get to go inside home, learn this long tail cases where our robot does fail and get to 99.9999% accuracy, and that also comes better from consumer space than enterprise.
I guess one of the, just this is a high level question as well, because I think it goes back to the point that you've made a few times, right? Like this is obviously a new product. The space has been around for a while. There still
Hmm.
doesn't seem to have that huge adoption. Like what does the next
Hmm.
5, 10 years look like? What do you think are going to be some of those triggers where actually robotics and kind of what you're building out now becomes a
Yeah,
mainstream? Everyone has one, everyone wants to order. Like curious what your landscape looks like there.
I think this is where I'll just borrow Apple or Steve Jobs' word. It just needs to work. Can I get a robot, set it up, and it does what it does without me having to constantly supervise it, constantly rescue it, constantly, pull wires out of it? Internally, our joke, and wires are such a tough thing. Internally, our joke is that if killer robots ever came, just throw wires in front of it, and you're most likely your problems are solved. Because it's such a, and this is, if you think about it, we as humans we are obviously way better in terms of intelligence, at least the best intelligence example of the world, and we still sometimes get tangled up in wires. There is no perfection. So in that scenario, for robots, this is even hard. So just getting to a point where it just works, that it can adapt to all kinds of situations, that it's not going to chew my kids' Legos or take my necklace that mistakenly fell on the floor and suck it up. If you can get to that accuracy level where it just works, then you have a good product, and that's what it would take. I don't have to worry about it. So, and that is precisely what we actually measure. Just like Waymo and Tesla talks about disengagement per mile or miles driven per disengagement. In the same exact way, we talk about miles cleaned or square feet cleaned and drove without users having to rescue it. And that's really where our accuracy level comes on. So we genuinely believe it's that.
I candidly tripped over a cord literally yesterday, so it's a very human problem that has yet to be solved. I have one more question, then I'll kick it to Nolan to end with our
Sure.
final questions that we always ask folks. But we're sort of, and you alluded to this as well already, Mehul, around just like the landscape of robotics that we're in today. And it feels like there's this huge investment happening in humanoid robotics. And like,
Mhm.
even as somebody who's close to the action, it's like kind of not clear how much things are actually working versus like how much like the sort of ability to make good demos is sort of like the barrier for that is going down. I'm curious what your reaction is to sort of the meta landscape for robotics, but also like, what you think the timeline for Matic is, maybe not to ship a humanoid robot, but like, something with a hand or a claw or like some like beyond just like the driving
So,
use case, what you think the timeline for that looks like.
great question. So, overarching meta space was I'm actually super excited about what's happening in robotic space for the last 2, 3 years. It's amazing that robotics is finally getting attention. It's also amazing that there is a lot more home robotics oriented use cases getting solved as well. So finally, we see different perspective, different kinds of stuff. So all that stuff is really, really exciting, including the enthusiasm demos, because ultimately we need more intelligent, smart people to come into this space and innovate. We alone aren't enough. So that's always great. In terms of timeline, uh, if you just take humanoids, I tend to, at least my 2 cents for what it's worth at the moment, is that these are sort of a self-driving car 2.0 projects, in the sense that it took about 10 years for us to get to a point where we can take Waymo in SF, and you have a pretty good Tesla supervised FSD system. At least for me, I can go from my work to my home without disengagement pretty consistently now, which is mind-boggling. Um, so that level took about 10 years, and I think that's sort of the trajectory that we're going to get to, which is it will do one or two tasks or specific things inside factory very, very well. So I can totally see Optimus being in a line doing some work for Tesla in 2, 3 years. But in terms of general purpose robots where they can solve all kinds of problems and figure out what problems they need to solve, that's probably 5, maybe 10 years away. In home, I think challenge is even harder. um, and there are two. I will put my product hat on this thing, and I think Logan, earlier you alluded that in home customers are far more, in some ways, apprehensive or risk averse. They don't necessarily bring technology really, really fast. And great example of this analogy is actually General Magic, a company that ex Macintosh team started, which Tony Fadell, who ultimately invented iPod, iPhone, and Nest thermostat, worked at. That was his first job. And they tried to literally build iPhone between 91 to 95. They have the images of a brick with the app and everything drawn out on the paper from those days. There is an amazing documentary on it, and obviously massively failed because it was just too ahead of the curve, and people didn't understand even what the device was. And instead what we got is first the cell phones, and then we got the PDAs, and then we got the Blackberries, and then we got the iPods, and then at some point as a user we're like, oh, I don't want to have four devices that I carry. And then iPhone and smartphone and Androids became very valuable point of view. In the same exact way, inside homes, I tend to believe that you're going to have a single purpose robot proliferate first. Users will learn to trust them, learn to rely them before shelling out 20,000, 50,000, whatever it is to bring humanoid robot in. And the another way I'll kind of touch upon is the price point. So if you take a step back and think about it, cars have been around for 100 years now. Each of us know the value of it. We know that they're insanely helpful. Utility is great. They last for at least 5, maybe 10 years. Yet, if we're going to buy a $20,000 car, that's a considered purchase. We don't make an impulse purchase on this thing. If you're buying a $20,000 robot, well, what sort of utility it has to give? What is the killer use case? Is it laundry? Is it dishwashing? I don't know what the killer use case is as well. We can say it's laundry, but would you spend $20,000? And some would say yes. But if you take about the ubiquity and mass market, that's a very different scenario, right? And then what is the reliability? Is this something that's going to last you for 2 years, 5 years? Because cars last for 5 years. So what would customer expect here? And then can I trust it to, as a father of three kids, can I just trust it to not fall on my kids? And this is one thing that I tend to at least worry about quite a bit in robotics, because I don't think you can ever find a news article that says 95-year-old grandfather fell on top of a toddler or a kid or a pet. That never happens. We as humans fall down all the time, yet our control is so amazing that we never fall on any of things. We'll somehow manipulate to make sure the kid is saved or the pet is saved, right? You don't hear another human being falling on a baby ever. So can you get to that sort of accuracy? Because what happens when the first time a humanoid falls on a baby? That 60 pound of thing. So accuracy level. So this is where I tend to put a lot more of a product hat and come from a perspective of what is really the expectation of users and what sort of accuracy will user expect. And there will be early adopters, but the mass market deployment is a whole different story.
Yeah, that was made a lot of sense to me. Last two questions we like to ask all of our guests. First is, what does your personal tech stack look like? What are you using day in and day out that helps you accomplish what you're working on?
Um, for me, at least internally at the moment, we are entirely Notion shop and a Slack shop. So Notion and Slack is one, Google Meet and all the Google tools. And then in terms of a new AI tool, I think I use Perplexity quite a bit. They do a phenomenal job of search. I've used Claude as well, and lately actually using Gemini deep research quite a bit as well. That's something you worked on, Logan. So I just started playing around with it, and I'm a fan of some of those things. So we try that. I don't necessarily code at the moment. So coding environment is the killer app, but I don't use that as much. And then try to use few images to sometimes if I'm doing any sort of presentation, I will ask um, image generator to create images for me. And yesterday we discovered that you cannot get any image generators to create an image of a overflowing wine glass or completely full wine glass to the rim. If you keep asking it for whatever reason, it just keeps giving you half glass. And maybe that's because no one actually pulls, pours wine all the way to the rim and takes a picture. So it might be worth playing around with it. At least I couldn't get it. Maybe you guys will figure it out. But yeah, we tried a few once.
That's very, very interesting. Last question too we like to ask is, obviously we're in February, mid-February of 2025. What is one thing you hope happens in 2025 and one thing you hope does not? We'll kind of leave it broad for you to interpret.
I I think it would be amazing if the self-driving car becomes pretty ubiquitous across the board. So I think that's where deployment of that would be amazing because I think that would finally make mainstream consumers realize that AI in a physical world is doable and actually make them more acceptable to the AI in general, and that includes robotics as well. So I think there are huge benefits of that technology finally fulfilling its promise. So I hope that happens. And then on a second side, I do hope that people somehow uh, start realizing that robotics promise is still on a flip side, that it will take time before it becomes really, really helpful as well. So both,
I
which
love
is,
that.
uh, yeah, robotics is unfortunately inundated with over promise and under delivery. And I'd much rather we get into a place where we under promise and over deliver to
Yeah,
users.
I'm with you. I'm optimistic. I think 2025 is going to be a great year for folks building in robotics. Just to close things out, Mehul, thank you for taking the time to chat with us. How do folks get their
Mhm.
hands on a Matic robot? Like, what is the place? Is it the website? What's the place for them to go to if they're interested?
At the moment, website is the best place. You can go to maticrobots.com. You can pre-order it. If you're pre-ordering it today, it will ship most likely end of March, early April. We're about 4 to 8 weeks on a cycle. And if you listen to this podcast all the way, well, you can use Matic 100 as a code and get $100 off on your pre-order as well.
I love that. Wonderful. Saving people money, telling them about robots. What a great day. Mehul, thanks for taking the time to chat with us. This was a ton of fun.
Likewise, it was great. Thank you for all your questions and appreciate you patiently listening to everything. Thank you.